Okay, 2.2 slopes, rates of change. That's what we're dealing with. Here we have a graph, and I will use this graph and a line on this graph to define slope and rate of change. So let's say that there's this line. It's going to go through -3, -4. There we go. And let's say it also goes through 5, 1. Okay, so see if I can draw a line here and extend it out. Okay, here's a line. This line goes through these 2 points. Let's label these points. -3, -4. And 5, 1. Alright, so the slope is defined as the rise over the run. It is this fraction that we make up that compares the vertical change between these 2 points over the horizontal change. Okay, so let's say slope is this letter, let's call it M, and it is the rise over the run, and this rise would be vertical, and this run would be horizontal. Okay, we get the vertical rise over the horizontal run. That defines the slope. So if we go up, you know, how far up do we go from this point to this next point, and then how far over do we go to get there? And it's kind of like instructions on how to get from one point to another point. From this point, go up how much? We're going to go up 4, we'll go up another 1, so we'll go up 5. So for this line, the slope is 5 over, how much do we go over? Well, we start here and we go over 1, 2, 3, 4, 5, 6, 7, 8. So the slope is 5/8. And if I told you a point and I said the slope is 5/8, you could go up 5 and go over 8, and you could draw another point and draw the line right through there. Okay, so that's what the slope is useful for. And that is basically it. The way we would use a slope right here is just like I said. If you have a point, let's go up this much and over this much, and we'll know how to get to the next point. Okay. So that's basically it. That's what the slope is. So what if I? We'll work with that as sample problems. So that's it there. So now let's try and classify lines by their slopes. What if you had a line that was from here to there? It was, I think of this as uphill, because you start down here and you go, we read from left to right, so we look at things from left to right usually, and this one goes up. So if it goes uphill, then what kind of a slope does it have? Let's say there's a point here. Okay, let's get to another point, you know, further to the right of that point. Let's say this point here. And I'm not going to use actual numbers because I don't know what the numbers are, but I do know that I'd go up. So that rise would be, what kind of a rise? It would be a positive rise. Over, what would we do then? We go to the right. That's a positive move in the horizontal direction over a positive run. So a positive rise over a positive run makes a positive number, a positive slope. So uphill lines have positive slope. Okay, and that would be true for any quote unquote uphill line, whether it is slanty like that, or it's much steeper, or it's much less steep. All of these, to get from one point to the other, we would go up, that's positive, and to the right, that's positive. Positive rise, positive run. Okay, how about a different class of line? one that goes from here to there, what I would call, quote, downhill. So if it goes downhill, what does that mean? If we started at this point, let's just go from left to right. That's why we call it downhill. Well, to get vertically to this next point, we'd go down. And in the vertical realm, that's a negative thing. That's a negative rise. Okay. And then for the run, we'd go positive. Right? We're choosing to go to the right from the left to the right. So we're going to have a positive run. What kind of a slope is that going to be? It's going to be a negative divided by a positive. That's going to be a negative slope. Okay. So and that would apply to any line that goes, quote, downhill, whether it's really steep or really, really shallow. You can see that you would always go down in rise and to the right in run. Negative rise, positive run for a negative slope. Okay. What about let's pick this one. A slope that is, what would we call this? Flat or horizontal. A horizontal line. So we pick a point here and a point here, and we'll do the rise over the run. So this is horizontal. Okay. For the rise, what would we do? How far up would we go? Well, it's horizontal. It doesn't go up or down. It just stays perfectly flat. So when we try to go up for the rise, well, it's a 0. It's always going to be 0 for a flat line. 0 rise, non-existent rise. Doesn't go anywhere. And then the run would be, well, it doesn't really matter what the run is. It'd just be some, let's just call it a positive number. A positive run. So what's 0 divided by anything? 0 divided by positive or negative, it doesn't matter. Always 0. So a 0 slope for a horizontal line. Okay. Here's maybe the trickiest one. What kind of a line is this? It's perfectly up and down, so it's vertical. Okay. Here's kind of a tricky one. I mean, we can't go left to right, so this isn't left and this isn't left, and neither one of these are right, and so we'll just pick one. We'll pick the top one, maybe. Okay, we'll do the rise. All right, so we have a negative rise, let's say. And then we go down this way, and how far over do we go? We don't go over at all. We have come down, and we are at the next point. So there is no run. It's a 0 run. The number 0. We could do the other way. We could start at the bottom and go to the top, and we'd have a positive rise over a 0 run. Okay. Well, so we have this negative number or this positive number, both of them divided by 0 because the run is 0. How do you divide by 0? The quick answer is you don't. You can't divide by 0. So don't even try. Dividing by 0 produces what we call an undefined number. So for a vertical line, we have an undefined slope. Undefined. I mean, what do we mean by undefined? It means there it is. It's divided by 0, but it doesn't mean anything. It's like this word. You know, what is the definition of this word? It has no meaning. It doesn't have any definition at this point. We haven't defined this word. You won't find it in the dictionary. It's not defined. It's undefined. So this slope, it doesn't have a definition. And for our purposes, it's just not useful. It's like it doesn't even exist. So we might say it has an undefined slope, or maybe that the slope doesn't exist, because really it doesn't. If something doesn't have a definition, it's kind of like it doesn't exist. I guess we could get into a philosophical argument about that, but we won't. Not now, anyway. Okay, let's talk about if we had two lines that were this. I'll draw it, and then you think about what these lines are to each other. How am I deciding how to draw this line here? I've drawn these lines, so hopefully if they are extended for forever and ever, they would never touch, and that's what we call parallel lines. What would we say about these parallel lines? Well, and their slopes. Let's put these points here and these points here. Okay, so we would go up this much to get to this next point. And what do you think we would do? How far up would we go to get to this next point? We'd go up the same. And then we'd go over this much and go over just the same amount. Parallel lines would have the same slope or equal slope. Okay, lines are parallel, slopes are the same or equal. Okay, so if two lines run right along next to each other, in order to keep from touching, they would have to go up just as much as each other and go over just as much as each other. Otherwise, if one did something slightly different, it would eventually crash into the other one. Okay, if you want to drive alongside another car and not crash into them, you'd better match them move for move. If it, up just as much and over just as much. Otherwise, you're eventually going to collide with them. So that's parallel lines. What about two lines that are, what's this called? And maybe if I put a little angly thing right there, you recognize these as being perpendicular. That means they have a right angle in between them. So two perpendicular lines. What about their slopes? Okay, so I decided to redraw this so that the next thing that I draw is going to make more sense. So let's look at this line here and start looking at its slope. Alright, so we got the rise and the run. I'm going to draw another rise over run thing here for this other line. Okay, I'm going to draw it just like this. Okay. Actually, let's make it a different color, maybe black. Okay. So here's the rise over run for this line, here's the rise over run for this line. Okay. So this rise over run, let's call this A and this B. Alright, so let's now notice some things about these two. What we have now are triangles. Well, this one's going to be a right angle here, and this one's going to be a right angle here too, so that's pretty clear that the rise over the run would create a 90-degree angle. And what we have here is this little tiny angle on this triangle, and this big angle here on this triangle add up to 90. That's just the way we've drawn it. So if these two add up to 90, then let's say this angle here and this angle here, this will be a different angle, of course, so we use two arcs like that, like from geometry. There'll be two different angles, but they'll add up to 90. Well, what do you know? These two angles, this angle and this angle, also add up to 90. So this angle and this angle add up to 90. This angle and this angle add up to 90. So this angle must be the same as this angle because it adds to this angle and make 90. And by the same reasoning, this angle, must be the same as that angle. So we have here are two, at least right now, similar triangles. But what if I point at this side here and say that this will be the same as this, you can see that these two short sides would be similar to each other. And if I actually make them equal, this side is B and this side is also B, then this side must be as big as A, right? This must be A, only it must be negative A because it goes from here to there. Okay, so that is kind of a long way of saying that the slope for this line, the slope is a rise over b, rise over run, a over b. Okay, for this line, the slope is rise, which is b, over run, which is negative a. So that makes this fraction a negative one. Negative b over a. So this is a over b, and this is negative b over a. Okay, so there are two things. These two slopes are negative of each other. This one's positive, this one's negative, so they're negative. They're also flipped over, which is called the reciprocal. They're negative reciprocals. Okay? So if they're parallel, they have the same or equal slope. If they're perpendicular, they are negative reciprocals of each other. The slopes are. Okay. Awesome. Now let's say, just for example, that you're driving at 60 miles per 1 hour. Okay. I guess that should be mi. 60 miles per 1 hour. So if you were to draw a graph of your progress over time, you would go rise 60 miles to 1 hour. So 60, there's 60 marks right there. 60 miles to 1 hour. Okay. So there, after 1 hour, you would be 60 miles away, and then you would keep doing that, and it would create a line if you're driving 60 miles an hour all the time. So check that out. That if you were to draw a line of your progress over time, what you've made is a slope, or a line with a slope. So this rate of change, that's what we call that. That's something is changing versus something else is changing. As time goes on, miles goes up. That's a rate of change. It's also, if you graph, something like, well, you would take 60 miles per 1 hour, and if you want to know how far you've gone, you would just multiply it by how many hours have gone by. You would just multiply it by x, where x is the number of hours. Okay? And so if you were to graph this as a line, then it would be, well, as a function, as a graph, it would be a line, and that line would have a slope. So the slope and the rate of change they're interchangeable. The slope and rate of change are interchangeable. Okay, and that is it for the intro to 2.2. So I hope you had fun. I did.